I'd rather you didn't. Okay, this is day 2 on inverses. You hopefully realized that inverses were pretty easy, the part we did yesterday. These are still easy today. I mean, they're a little less straightforward. We'll just put it that way, okay? But this part of it is used a lot in calculus. And when I asked students what they were doing in calculus that we didn't do enough of in pre-calculus to get them ready, this was one of the things they said was more stuff on inverses. And you're not going to like this, making you memorize the inverse stuff. Just what quadrants they're in and that kind of stuff, okay? No, it's not hard. Okay. All right. This question is one where that's not on the unit circle anywhere, right? I'm not going to find a tangent of 3/4 on my unit circle. So you're going to have to draw this, okay? If it's not on the unit circle, you're probably going to have to draw. Now, this is an inverse tangent that's negative. Inverse tangent is in what 2 quadrants? 1 and 4. Okay. Inverse quadrant is over here. Where would it be negative, in 1 or 4? 4. So we're going to draw a triangle down here in quadrant 4. That triangle has a tangent of negative 3/4. Where would I write those numbers on my triangle? Tangent is opposite over adjacent. It says a negative though. Where am I going to put the negative? How do I know? Yes, this y coordinate down is negative 3. How am I going to find the hypotenuse so that I can go forth and find the cosine? Yep, Pythagorean theorem. Hypotenuse squared. So I get 5. Everybody all right that that's a 3, 4, 5? So what is the cosine of that same triangle? Adjacent over hypotenuse is 4/5. So that wasn't a very difficult question. We've had to do things where they told us, you know, a point has on its terminal ray the ordered pair 4, negative 3, and then we had to find the tangent or something. It's kind of the same thing. All right. So let's see if we can handle these. Do we need to draw this one? No. That's on our unit circle. What is the sign? Okay. You need to make sure you're asking these questions of yourself correctly. This one is straight up sine, not inverse, right? So what is the sine at pi over 3? You go to pi over 3 and the sine value is? Okay, and then you are trying to locate the arc cosine or inverse cosine. So an angle where the cosine is square root of 3 over 2. Remember, cosine is the x coordinate. And we get pi over 6. Everybody okay? If you're not looking at your unit circle, this is making no sense. We're just pulling things out of thin air. All right, is this one going to use the unit circle? No. If we draw this, which quadrant am I going to be in where the arc tangent is positive? Quadrant 1. All right, we're going to do tangent is opposite over adjacent. Arc tangent means inverse tangent. So it's, yeah, it's the same thing, different notation, different wording. I don't know why there's such a thing. I wish I was a genius in all the knowledge of why mathematical things, you know, what the history of that is, why there's 2 different ways to write it. I don't know. Yeah, that's it. I made up a new thing. That's it. All right, guys. How do we find this side? Pythagorean theorem. Anybody know that one? Yep. So this is 13. So the sine at that triangle is? Opposite over hypotenuse. So we get 5/13. cosine would be 12/13. Is everybody okay? All right. Yes. No, because arctangent, remember how we shaded? Yeah, it has to be in quadrant. Yep, good question. Otherwise, we wouldn't know. You're right. That's a perfect question. Can't be in quadrant 3. Arctangent is only defined in quadrants 1 and 2. All right. There's an example here. I'm actually going to skip this because it introduces new variables that I'm not all excited about because your homework uses x. All right, you have this question? Okay. Sine of the arc cosine of x. Okay. We're going to put this in quadrant 1. One of the worksheets actually says to use quadrant 1, but we're just going to assume that we're supposed to use quadrant 1 and assume x is positive. Okay, cosine, I'm trying to find where the cosine, some angle, is x or x over 1. Cosine is adjacent over hypotenuse. So on this triangle, I'm going to put x on the adjacent side and 1 on the hypotenuse. So where is the cosine? Adjacent over hypotenuse, x or x over 1. Now we have to write an algebraic expression over here. All right. If we do x squared plus something, I'm going to use question mark, squared, equals 1 squared, how can we solve for question mark? 1 squared is what, guys? Just 1. Then we have to subtract x squared over there. Very good. And the last step to get question mark all by itself would be just square root. So that expression we can write on that side is the square root of 1 minus x squared. Now, does that simplify? Can we just write 1 minus x? I see lots of nodding. If we could just write 1 minus x there, would we need Pythagorean theorem? If this whole side is 1 and this whole side is x, and we subtract those, we will not get that side, right? If you added those together, you'd get this. Is that true? Guys, remember we've had this conversation in the past? We all agree that that's true? Okay. So if you square root both sides, you guys want me to say this is true. You can't square root because the order of operations would say you have to square before you could square root, and you have to add. Okay? So we cannot simplify this. And you have to know this for calculus. You have to do lots of these where you write expressions here. All right, so now what is the sign of that triangle that we've finally gotten labeled? Sine is now opposite over hypotenuse, so we're going to write what? Square root of 1 minus x squared over 1, or just the answer is square root of 1 minus x squared. All right, let's try another one. Where the sine is x, so sine is x over 1, or opposite over hypotenuse. Is that the same triangle we were just drawing? Same labels? Opposite over hypotenuse, right? So the x is over here now. But the expression down here, still going to be, what? Yeah, we're going to find the cotangent, but the expression that we need to write down here is still going to be hypotenuse squared minus leg squared, or 1 squared minus x squared square root, right? And they want cotangent in the end. Cotangent is adjacent over opposite, right? I wrote that wrong. So what is adjacent over opposite for this triangle? Adjacent, opposite. Final answer. All right, a little more practice. This one is very similar to one we just did. It may even be exactly the same. I have no idea, but cosine.
That is the same thing.
Cosine is adjacent over hypotenuse, so we have adjacent over hypotenuse. What goes here? Okay, so what's the sign of that? Opposite over hypotenuse would just be square root of 1 minus x squared, or over 1, or just square root of 1 minus x squared. All right, we did that one already, sorry. This one, sine is x. Sine is opposite over hypotenuse. What expression goes down here? Okay, that's not always going to be true, but we'll do some on the worksheet amendment that shows you when that's not true. Guys. Okay, this time it wants tangent. Seems like it shouldn't be that hard, but tangent is what? Opposite over adjacent. And guess who's not going to let you leave that in the denominator this time? Okay. So when we had like 7 over square root of 3, we wound up with 7 square roots of 3 over 3, right? So when we do this mess, what are we going to end up with on the top? Good job, Getty. Now wait till you have to find the derivative of that. Yeah. Calculus fun. Okay. A lot of algebraic messy work. All right. Let's do a quick review. Everybody have their unit circle handy? Where is the sine, the inverse sine, square root of 3 over 2? So where is the sine square root of 3 over 2? Nope.
No, okay. Oh, it's positive, okay.
It's positive square root of 3 over 2, not square root of 2 over 2. So it's pi over 3. Everybody okay?
Yeah.
Tangent is the tricky one because tangent isn't on our unit circle. By the way, the only things you can write on here, guys, are those negative things and your color coding, okay? You can't write tangent by all these, or I'm going to hand you a clean one the day of the quiz and you're not going to have anything on it. You have to know how to find tangent. Well, tangent would be -1 when the x and y coordinates are the same, right?
Yeah.
Except one of them's got to be negative. Yes, because we got to be down in this quadrant, it's negative, and the coordinate would be square root of 2 over 2, negative square root of 2 over 2. That would have a tangent of -1. Okay. -0.5. Oh, this is sounding all tricky, but -0.5 is really just -1/2.
Yeah,
Be careful. What quadrant is our cosine negative? Second quadrant. So we had, okay, yep, you guys said it right. I was just making sure everybody was with us. Where is the tangent positive square root of 3? For tangent to be square root of 3, we need something like this, yes? Because we need the y over the x to come out square root of 3 over 1, or just square root of 3. So that occurs at Pi over 3. All right.
I'm out the monkey wrench again.
Now some crazy business. Shh, ladies. Cosine, where is the cosine positive 1?
0.
It's 0 radians, and it says, what is the sine of that place?
0.
It is 0.
Oh, I want to delete it like that.
Okay. This is a crazy one. I would not ask you this, but arc cos. First of all, is this possible?
I'm saying no. Wait.
The only way you can tell is cosine has to be less than 1, right?
Yeah.
This is not on our unit circle. There's no way on the unit circle that has that cosine value. But square root of 3 is like 1.7, okay? So this is less than 1, so it is possible for some weird angle somewhere to have that cosine value. If it's not on the unit circle, I draw it. Cosine is adjacent over hypotenuse, which is crazy. What does it want, though? It just wants the cosine of that angle. So the answer is, which really I wouldn't like as an answer. Yeah, this is just undoing itself. Okay? That's a weird one, though. All right, this one. Can you guys try this one on your own? Draw this, right? Because it's not on the unit circle. This can be a radical, isn't it? Sine is opposite over 5, 12, 13, but that's only if the hypotenuse. This is 12 squared minus 5 squared. Is it 129, 119?
119. Square root of 119. That's beautiful.
Right? Because we know the hypotenuse already?
Yeah.
You all right, Josh? So we end up with square root of 119. So what's the cosine? Okay. That was doable. Kind of painful, but doable. All right. This is one like we were just talking, ladies. This is one like we were just talking about where you have to draw. They're just telling you to put it in the first quadrant. That's all that business is. Okay. If I label the sine, well, I can't draw a triangle today. Apparently it's a trapezoid, but sine is opposite and hypotenuse, right? Opposite hypotenuse. So opposite hypotenuse. Now, this is where I need to be paying attention. This is not 1 minus x squared or 1 minus x squared. To find this, what do I have to do? Okay, from, so I have question mark squared equals, can I write it as 25 instead of 5 squared? So answer for that side? Yes, no simplifying. It's just the square root of 25 minus x squared. And what is the final answer then? It wants what? Cosine, which is, yes, the adjacent, 25 minus x squared all under the radical, divided by the hypotenuse of 5. Can I reduce the 5 and the 25?
Nope.
No. At least we were confident on that answer.
Can you put x squared minus 25? That's the same thing, right?
No.
No, you can't.
No, guys, it's x squared minus 25 and 25 minus x squared, same thing.
Oh.
Subtraction order matters, right? Order matters on subtraction. Yep, you can't switch the order on subtraction. It would just be outside the radical. You can't multiply underneath the radical by a -1. All right. This is the assignment on that. Before I stop recording, I want to do an example or two off worksheet 18 for the people at home. You guys got out worksheet 18?
Yeah.
Okay. There's a few tricky questions, but I want you to try these and struggle a little bit on your own. Can we look at, I think on C, I gave you a hint already on your notes, did I? Okay, it says on worksheet 18B, if the tangent is 4x or 4x over 1, tangent is opposite over adjacent. Opposite is 4x, adjacent is 1. Is this not worksheet 18B? Okay. We need to find something to write on the hypotenuse so that we can find the secant. This is the first time that we've had to find a hypotenuse. Okay, when we wrote weird expressions before they were on the leg, what is this weird expression going to be? Question mark. So we have 1 squared plus 4x squared equals hypotenuse or question mark squared. 1 squared is 4x, quantity squared is not 4x squared, it's 16x squared. Everybody all right with that? 4x times 4x? And then we need to do what? Square root, and is it going to simplify? No. That one you could write 16x squared plus 1 or 1 plus 16x squared. Yeah. Okay, you could write it either way. Now, what's the secant going to be? Secant is hypotenuse over cosine is adjacent. Yeah, it's hypotenuse over adjacent. So final answer? Yeah, square root of 1 plus 16x squared or 16x squared plus 1 all under the radical, because then adjacent is just 1. We good?
Yep.
Okay. Do you want me to try E or F? Are you okay? This one is a little odd. Last one. Tangent is opposite over adjacent, right? What are we going to get for the hypotenuse? Square this side, you get x squared. Square this side, you get plain old 3. You're adding, right? Leg squared plus leg squared would be 3 plus x squared, but then you have to square root. So there's the triangle you need for E, okay?
The order matters there. Cannot be x squared.
No, it can be x squared plus 3. Order doesn't matter as long as you're adding. That's a great question. No one else asked that all day because somebody's going to write it backwards and think they got it right. If it's addition, they will have it right, but if it's not, can't switch the order on subtraction.